Hello and welcome to Developers Heaven. Today in this video, I'm going to teach you Python on a crash course basis. So what is Python? Python is one of the most beginner friendly yet powerful programming languages out there. So it's a general purpose programming language that is used for web development, data analysis, and many more tasks as well. The beauty of Python is it's easy to learn and has very simple syntax. It is a very powerful programming language, so powerful that in the age of artificial intelligence, Python is used in data science, machine learning, and AI. And one more good news is it has a huge community and a lot of free resources. So if you're looking for answers for your question, if you're stuck with something, there are so many free resources out there on the internet you can quickly refer to and get out of that. So for developing Python, you can use IDEs like Visual Studio Code or Jupyter Notebook or PyCharm. In this video, I'm using Jupyter Notebook because of its ability to run cells individually. And this is the course we'll be going today, the table of contents. So we'll look at the basics of Python, the data types, and the string functions, conditionals, loops, functions, classes, and modules. So without a delay, let's get into the code. Coming to the basics, how do we write a comment in Python? So the comments in Python is written as hash followed by the string. So if I execute this cell, it doesn't do anything because it's just a comment. So this piece of code will not execute, but it's there for maybe writing some comments or documenting what some of your code does. That's how you write a comment. And then there is one more thing which is called print statement. So you just use print and within the strings do the text you want to print it, and when I execute the cell it will print this one. So this is one of the most ones we use for debugging purposes. So when we do this one, it will usually be printed in the IDE terminal, or if you're using it in web development, then it will be printed in the browser console. And let's see what data types we have in Python. If we categorize the data types into multiple categories, the first thing is the numeric types like int, float, and complex. So int is basically whole numbers, float is for decimal numbers, complex is a complex data type. I will explain you further when we actually get there. And there is another data type string, which is used to hold any type of strings or sentences you have. And then sequence, these are the most powerful and most used data types in Python: the list, tuple, and range. These are the collection objects. And there is a mapping object. This is also a collection, which is called a dictionary, which has key value pairs. We'll get into more details when we get there. And there is a Boolean type as well to hold the binary values like true and false. So looking at the general data types itself, a variable can be declared as like this: simply x is the variable, 20 is the value. So I've declared x is equal to 20. So the variable x holds the value 20. So there are some rules around how you can actually declare the variables. So you can name your variables containing alphanumeric characters like this. For example, variable is equal to 20. This is a valid one. Or variable 1 is equal to 20. This is also a valid one. Or 1 variable is equal to 20. This is also valid. It can't start with a number, sorry. It should start with an alphabet, or it should start with an underscore. It can start with underscore or alphabet, but it can't start with a number, or it can't have all numbers itself, because it will consider that as number. So those are the rules around the variables itself. And I'm here, what I'm doing is x is equal to 20. X is my variable, so I'm using print and the type of x. So if you happen to come from other programming background like C Sharp, Java, or TypeScript, I'm not setting the type of the variable right away, but Python will work out what type it is based on the value it is set. So in this case, we see x is equal to 20 and the class is actually integer. So it knows the value we have assigned is an integer, and it casts the type to be x. Whereas in here, when I set x is equal to 20.5, then it will work out the data type is float. And if I enclose the 20 in single quotes, then it knows that it is a string. And similarly, the boolean value as well, it is true here. And you must have already observed that the true T in the true is actually capital letters, unlike C Sharp or Java or JavaScript, where we have lowercase t as well. But in Python, we have T capitals in true and F caps in false, and the type is Boolean. And this is the complex type I was talking about. The complex type will actually have a real number plus an imaginary number. So real number is optional. You can just have an imaginary number here. I have not come across a place where I use this complex variable, but if you happen to work in a specific domains where you need to use a complex type, you will use that. But this is I'm explaining this only for the knowledge purposes. So you see the type here is complex. So if I have another variable here, y is equal to 4 plus 10j, and let me just print x plus y. So what happens here, it added the like terms here. 5 plus 4 is equal to 9 and 10 plus 7 is equal to 17, 17j. That's how this complex type additions, mathematical functions work in there. But I don't know a real world application of this one. I have not come across one so far. But if you have seen anywhere, you're happy. I'll be more than happy for you to comment and others to learn from this. And there is a list type. So what is a list? List is a collection of items. List can have items of different data types as well. And these lists are actually index based and mutable. Mutable meaning you can actually update the underlying values of those lists. So the way we declare list is simply a is equal to 1, 2, 3, 4. It's more like an array. And when I execute this cell, so I know the value of a is 1, 2, 3, 4, and the type is actually a list. And we can, it's not just for the numbers, we can have strings as well in list. So if I execute this cell, the type is still list, but this time the values are in strings rather than numbers. And you can mix and match the data types as well in lists. So like how we are seeing red and green or strings, and 2 is an integer, but still the type is list. And when I said we can access them or index based, if I want to get the first item of the list, then we can just use a of 0. A of 0 is red. If I do a of 1, then I will get 2, because that is the second item, because it's the index starts from 0. And if I want to update, like I said, these are mutable. We can update the value. So I want to update the first value to blue, so I just call it as a of 0, the index 0, the first item to be blue. When I execute this, then the list converted to blue 2 and green rather than red 2 and green. This red is updated with blue here. And there is a length function where it will return us the total number of items in the list. The length is 3 here because we have 3 items, 1, 2, and 3. And list also provides a function called append, which will append the values to the end of the list. So we have this a dot append of brown. So in the new list has the original 3 items and then the brown as well. And similarly remove as well. If I want to remove brown, then the brown is removed. I have these 3 here. And let me delete this. And a dot reverse, we can reverse the string. Blue, true, green, blue, true, green. Okay, I have not taken this into variable. I just have to call b is equal to a dot reverse and print b. It should actually reverse the values. We'll come back to that later. And we can sort as well. We can sort them. So it said it's not supported between int and string. If you remember, I have a list with numbers and strings, so it is not letting me do that. What I will do is I will just update the value of the first item from 2 to be red. Now this will actually sort in reverse order, in the descending order basically. But if I don't want it in descending order, if I want it in ascending order, I can just use straight away sort. That will do it in ascending order. And then tuple. The next data type is tuple. Tuple is also a collection of objects. This is similar to a list basically. This is also this can also have multiple data types, but the big difference is it is immutable. That means we cannot change the values. So once we assign values to the tuple, we cannot change it. So the way we declare tuple is this way: a is equal to 1 2 3 4. In the list we have done square brackets, whereas here it's normal brackets. If I do square brackets here, for example, and execute this cell, you see the class has changed to list. But when we use normal brackets, that's a tuple. And we can access the values on index base. So a of 1, so I'm interested in the second item, that's 2. If I do a of 3, then it will be 4, because the fourth item is 4. If we try to update it, a of 1 is equal to 5, then I will get this error: item assignment is not supported. That's what I was talking about, this immutable. A tuple is immutable, we can't update the values. And then the next type is dictionary. Dictionary is also a collection of items, but the items are collected in key value pairs. So for every item, there is a key and an associated value with it. Unlike lists or tuples, we cannot do this index based. We have to access the values by their keys. And dictionary is also mutable, meaning we can update that. So the way we declare a dictionary is a is equal to, it should start with the flower braces this time, and every item will have a key colon and associated value with it. Key colon associated value, key colon associated value. So this has the length of 3 here. So when I run this one, that is the first key value pair, this is the second key value pair, the third key value pair, and the type is actually dictionary. So if I do a of 2, what it is doing is, this is an assignment. Let me just fetch a of 2. So what I'm doing is I'm trying to get the value of key 2. A of 2 will be green. If I do a of 3, this will be red. And like I said, it is immutable. So if I set a of 2 to be 5, I'm commanding the item with the key 2 be updated to 5, which it does. So the item key is updated to 5. If you want to see all the keys in the dictionary, we can use the function a.keys that will return all the keys only. And if you want to see everything, then we can get items that will return the key value pairs. So that's about the dictionaries. Let's jump into string functions. So here I've taken two variables: name is equal to John and age is equal to 30. If I do John 30, these are the two values I got here. Now the first thing we want to look at is concatenation. How do we concatenate strings? So when we want to concatenate, it is like in any other programming language. You can have a usual string plus the variable you have that will do hello, I'm John. Hello, I'm John. That's good. So we can also concatenate with strings and integers. So I will remove this for now. So concatenate with string and int. In this case, our name is actually a string and age is integer. So what I'm doing is, hello, I am John and I am 30 years old is what I want to see. If I execute this cell, this doesn't work because it cannot concatenate a string with the integer. So when we have a string and an integer, what the programming language thinks is this plus with integer, it is trying to add up, like 2 plus 3 is equal to 5. So it is saying that I can't add this string to this integer. One way to address this one is we can typecast by converting this into string, the age into string. And if I run this cell, hello, I'm John, I'm 30 years old. So this works usually, but this is the less preferred one because we have more powerful concatenating techniques available in Python. So this is for knowledge purpose, but this is the least preferred one. The next concatenation is concatenating by arguments. So what we do is we have an entire string here. Hello, I am name within the brackets like this. That's the argument, and within this flower braces, this is another argument. And in the end, I use the format method, the string format method. Here, I need to provide the values for these variables. So name is equal to name and age is equal to age. For example, if I have here first name, let me just run this cell as is. So I am John, I'm 30 years old. If I do this one as first name and execute this, I will get the error first underscore name is not available because I'm trying to access a variable first underscore name that is not available here. It only has name. So what I need to do is I need to set first underscore name, then this will work. So that's how the formatting works. Whatever the variables you are using within the string will expect those to be in the format string. And the next one is concatenating using the F string. This is one of the most powerful ones we use in Python. So if you happen to be coming from a JavaScript or a TypeScript background, this is nothing less than a template literal where we use template literals in tilde characters like this. So there is a tilde character, we have some string, and then a dollar, the variable name. So the same thing is happening here, but instead of this tilde character, we have an F at the beginning of the string. Hello, I am name and I am Jim. Again, the variables are specified in the flower braces here. So if I do this one, I get the exact same result. And this is one of the most commonly used concatenating string concatenation technique in Python. And string will also provide so many functions for us which we don't have to do ourselves manually. So if I want to capitalize this one, hello world is a string all in lowercase. If I want the first letter of this string to be capital, then I can use the capitalize function, then the first string is converted into caps. If I want everything in upper, then we can do dot upper, it will do hello world in uppercase. And similarly, this is all in uppercase. I want it in lower, then there is a lower function, and we can also swap the casing. Here, the uppercase became lowercase and lowercase became uppercase. That's how the swap case works. And then we can also use the length function on the string to get the number of characters on this one. So if you count this one, it will just be 10 without the space, but with the space, it becomes 11. And then there is a replace function as well. So hello world, I'm replacing this world with all. So my output will be hello all. And it doesn't have to be a complete word. If I just use WOR itself, then it will return just that part of the string with all. So that's how it works. And there is another thing which will determine starts with H. It will return a Boolean value because we are asking a question, does it start with? So if it starts with H, then it will return true. And remember, this is case sensitive. If I do a small h here instead, then it will return me false. And you can give any continuous values. It will return true as long as that is matching. So if I do hell, then also it will return true because it starts with the hell. So it can be in number of continuous words there. And the similar way we have ends with as well. It works the exact same way. This is also case sensitive, but now we are asking a question, does the string end with this one? And there is a split function here. So let me get rid of this one and just use the hello world for now, and I will just use the split. So what it does is it will split the words into a list. It will split the words and return a list for us. By default the delimiter is a space. So if I add one more word here, then it will have an array of 3 because it has 2 spaces. But if you want to specify your own delimiter, then you can do that by having 2 delimiters here, and then you have to specify the delimiter in the split function itself. then again it's hello world world. So if I remove one of the comma here, then it will just be 2, because there is only one comma. It will split in, it will have an array of 2. And then positioning. So you want to position what's there in the string. I want to get the position of, let's say, O. So it will look at the first one and stop it. So in this hello world, I've it's written as 4 because the index is based on 0. So it will be 0, 1, 2, 3, 4. Hello. If I do H, it's -1. Again, this is also case sensitive. I will just write it here. This is also case sensitive, but if I do a capital H, it will return 0. So if you're doing something, a character that does not exist in the string, for example, Y, then it will return -1. And there is another function, is alpha. We want to find out if a string is made up of alphabets. It will return, again, it will return a Boolean value, true or false. So hello world, all are alphabets. It can be uppercase or lowercase. It can all be, yeah, is alphanumeric will tell us if the string is actually made up of alphabets. So it can be lowercase, uppercase, but it needs to be alphabets without any numbers. So if I add a number here, then it will return false because it's not in alphabets. If I do a space, it will still return false because space is not considered as an alphabet. It's a special character. So if it's just made up of alphabets, then it will use is alpha is true. And we can also find out if if the string is made up of just numbers, and similarly alphanumeric as well. So here it will accept alphabets as well as numerics, but if I add a special character like hash or at the rate, then it will return false. That's how these are the functions, most used functions we have in Python strings. And let's move on to conditionals. Here I'm taking two variables, x and y, assign the values 10, 20. So I should have told you this in before. Instead of declaring x is equal to 10 and y is equal to 10 like this, the simplest way is that we can just do x comma y is equal to 10 20. So it will assign the value 10 to x and assign the value y to 20 respectively. So this is a simple way of declaring variables. It's not just for integers, we can do for any data types as well in a continuous manner. And the simple if condition will look like this in Python. So if you're fairly new to Python and you're coming from a different programming language background, then we need if x is greater than 1 and then a colon, and these indentations are very important in Python. So if I have an indentation here, so let's run this command as it is first. So if x is greater than 1, print x is greater than 1. If I do this, then we have printed x is greater than 1. I will write another print command without the indentation. So this will print anyway. So with this indentation, what happened is the if loop ended here, and this is a separate statement now. So irrespective of this condition, this will print. So that's what we are seeing here. So indentation is very important. If I add a little indentation here, then this will print only if the x is greater than 1. So we have x is equal to 10. Let's do x is equal to 11. Then nothing will print. But if I move this indentation a bit back, then this will print anyway, because this statement is not part of this if condition anymore because of this indentation. So remember, the indentation is very important in Python. And the else condition is used like this. So if x is less than 1, print x is less than 1. Again, the indentation is important here. Else, we need a colon at the end of every statement here in Python. So x is greater than or equal to 1 is what I got. So if condition is not satisfied here, but else condition is satisfied. And there is a ternary condition here. So instead of doing all this, we can just use a simple if else condition here. What this statement is saying here is, give me x if x is greater than y, else give me y. So this is one line if else condition. So this is called ternary condition. If I run this, it will give me the value of y because x is not greater than y. If I inverse this condition, if x is less than y, then obviously I will get 10 because x is less than y. So basically what happened here is give me x if x is less than y, else give me y. That's all it is. So I hope you understood the ternary condition here. The next one is elif. So if we have multiple conditions, we can use if else if, whereas in Python it's not else if, it's elif. So if x is less than 1, do something. Elif x is equal to 1, do something. Else, for everything else, do something. That's how the elif works in Python. And we can also use the operators. It's not just limited to this one. We can use is equal to operators like w is equal to here. This is not is equal to, less than or equal to, greater than or equal to, less than, greater than. All sorts of operations we can use. So if x is not is equal to y, then do not equal. If x is equal to y, then type equal. Here it's showed equal because I used the not. So this not xw is equal to and x exclamation not is equal to, they both are the same thing. And then it also supports logical operators like and or. So we can do multiple conditions here. So if x is greater than 5 and x is greater than 7, then print x is greater than 5 on 7. That's what it does. Or we can do or operator as well. So what happens here is, in order for this print statement to execute or for this condition to satisfy, then x should be greater than 5 and it should also be greater than 7. Whereas in this case, one condition satisfaction is enough because it is an or operator. If x is greater than 5 or x is greater than 7, then this statement will execute. That's the or condition there. And we can also use nested ifs. So if x is greater than 5, do something, and we can have a further condition. If x is greater than 10, do something else. So if I execute this, x is greater than 5, but it is not greater than 10. That's why this condition did not execute, only this has executed. If I do x is greater than 9, then we will see both the conditions being executed. So that's how we use nested if conditions here. And remember again, the indentation is very important. If I move this here, then this will be treated as two if conditions. Because of this indentation, this is a nested if condition here. And one more thing, it will also support is and is not as well. Consider I have two lists here. A is equal to apple, banana, cherry, apple, banana, cherry. And if I do A is B, print A is B, else print A is not B. So this is basically comparing the objects itself. So if I execute this one, what do you think the output will be? It will be A is not B. So you might wonder, it's apple, banana, cherry, but it's still saying is not B. That is because the contents of the list are the same, but the list itself is not same. This is a list A, this is a list B. They are two different objects. The contents are same, but the list is not same. That's why we are seeing A is not B. So instead of declaring this a completely different variable here like this, and if I say B is equal to A, in this case it will be equal because they are both referring to the same object. Whereas in this case, they are two different objects. And similarly, if I just make a copy of this, B is equal to A dot copy, it will still say A is not B because we created another instance of the list into the variable B. So we can use is not, and other operators as well. And then the loops. So when we want a piece of code to execute for a number of times, we use for loop. Unless you are a really basic or the beginning your programming right now, you will already have an idea on this one. So the for loop in Python looks like this. So for I in range of 5, print I. So what I'm saying is print I starting with 0 until 5. So this will print 0, 1, 2, 3, 4. So in this range function, this is accepting the maximum number of 5, and the minimum number is it always starts from 0. But what if I want my number to start from a different start index? So we can then in that case, this range function will take two arguments. First is the start index and the next one is the last index. So in this case, what I'm saying is start my index from 2, go until 5 and print I. So that's what it does, 2, 3, 4, and it will exclude the last one. Or you can specify 0 to start with 0, or if you don't specify 0 here, it will be 0 by default, right? And this range function will take another argument called step. So if I add a step 2 here, what it does is every time it will step two numbers, it will skip one number and go to the second one for every loop. That's how a simple loop looks like. And we can also break the loop based on some condition. So in this case, the same thing as above previously, but if I is equal to 3, I'm saying break and then print. So what this break does is it will come out of the loop completely. It will stop executing the loop. So let's see in action what this happens. So it printed 0, 1, 2. The next time it came to 3. If I is equal to 3, then break. The entire loop has broken. So when you want to stop the loop based on some condition, then you'll need to use this break. There is another thing called continue. So what this one does is if I is equal to 3, continue. So why does this continue execute? Does it not continue the loop already? Why should we use a continue? The difference is that continue will pass the cursor back to this for loop. So anything below this continue will not execute. So if you see in action, so for 0, 1, 2 it executed. When I is equal to 3, this condition is satisfied and it came to continue here. And like I said, the cursor will go back to the for loop again. So this will not execute. That's why we are not seeing print 3 here. Hope that makes sense. So if you want to continue the for loop but not execute the code below that one, then we will use continue there. And we can use for loops for lists as well, not just for numbers or range like this one. We can use this for list as well. So I have a list here, red, blue, green and orange. So for color, in colors, print color. So it will go to every item in the list and then do this one. If you want to execute the same list in this range fashion, we can still do that. So I will take the exact same array here. So how we can do using that range function is for I in range. So we need to give a number. What is my range here? It is nothing but the length of color. So previously we discussed that length function will give the length of the array. And then we can do print. What do we print here? So we have to print the item at the index in colors. So I have to do colors here. If I execute this, these two does exactly the same thing. But this looks like a much cleaner way for us, but it's your choice. You can do whatever. There is no difference in the way which is something is more performant or less performant. They're both nearly the same. It's just the way of writing code. And we can iterate through an array with dictionaries as well. So once it is an array or list. It doesn't matter the contents of the list itself. So the contents of the list can be numbers, floats, strings, or even dictionaries like this. So here I've used an array of dictionaries, and then when I execute this code, so for everything we have a dictionary being printed here. And there is a while loop as well. So I want something to be executed while the condition is false. For example, I'm writing a file to the file system, and while the file is writing, I want the code to stop there. I don't want the code to go out of this block. And I can't use a range function or a timer function because I really don't know how long it is going to take for the file to be written. So we can use a while loop there. So while the file is being written, just wait for that to happen. So what I've done here is while count is less than 10, print count and increment count every time. So if I increment this count to, let's say, 3, then the condition will satisfy quicker. And next thing we will be looking at is the functions. So what is a function? A function is a block of code that runs only when it is called. So the function is there, declared, it has the body and everything. But unless we call the function explicitly, that piece of code will not execute on runtime. So I've declared a function here. If I run this one, nothing happens because I have not actually called the function. So the way we call the function is print message, I mean the function name, and then whatever the parameters it is accepting. So the definition of this function in Python goes is you have to use the keyword def and then the message, sorry, not the message, the function name and whatever the parameters it takes, and then a colon next the body of the function with the indentation. Indentation is very important here. So if I use print message with hello there, then it prints hello there. Now this piece of code has actually executed. And here I have another function is even. So it will take a number and it will tell me if that number is true or false. It will return a true. So the difference between these two ones is basically this is not returning any value. So this is a void or a method you want to call it. Whereas this one is a function which will return a value. Here it just accepted the parameters and did something inside, but it did not return anything. We are not expecting it to return anything. Whereas here is even is a function. So I am expecting a return value. If it is an even number, it will return true. Otherwise, it will return false. So that is executed. If I call is even with 5, then it will return false. But I do is even with 4, it will return true because 4 is an even number. So that's how you return values from function. So if you have more than one parameters, you can add a comma and keep adding number 2, and when calling you will have to pass those parameters. And then one interesting concept in this functions is lambda functions. So lambda functions are not anything new to the programming language. They have been in most programming languages for ages. It is basically a small anonymous function, a function that is created on the fly. It can take any number of parameters, but it can only have a single expression. Like you can't have multiple lines of expressions. What I mean by multiple lines is your single expression can span multiple lines, but it should just have one expression like this one here. So there is a function lambda number 1, number 2. These are the two parameters I'm passing in, and then number 1 times number 2. This is basically returning the product. So if I call this function, it will return 5 comma 6 is equal to 30. So if you want to add some conditions here, like if number is greater than this one, do this. If number is greater than 2, this one, do this. In that case, what's happening is it is not a single expression anymore. It is spanning into multiple expressions. So that is not allowed in lambda. So these lambda functions are very, very important when we are iterating through an array and do some operations on the items of the array on the fly. So instead of creating a new function, you can use a lambda function, which is anonymous. That's how the lambda functions work. And then coming to classes. So the way we write classes in Python is you use the class keyword and the class name and a colon, and then this definition. When we see underscore underscore init underscore underscore, then this means this is a constructor. I will just add a comment here. This is a constructor. So every constructor or every function or every method in a Python class will take an argument called self by itself, and then any other parameters which we want them to pass. once we pass those parameters, we need to store them somewhere. So we store them in the self itself. So self dot first name is called first name, self dot last name is last name. I've added all those parameters here. When I have another function, this will also accept the self. So from this self, I will be able to access those values here. So here there is a function called say hello. This is the default one. The self is the default argument for every function in Python, and then return hello self dot first name and self dot last name. So here I'm creating the instance of this function. We don't use a new keyword in Python. We can just do p is equal to person. If you observe here, I'm only passing first name, last name, and age, and I'm not passing the self here because we don't have to pass that one. Like I said, it is inbuilt into that. We don't have to pass that. Now, if I say print p dot say hello, I'm expecting that say hello, it will be hello self dot first name and last name. So it will show hello developers heaven. That's what will happen. And there are private variables and protected variables as well in this one. For example, I've created instance of this person here and I'm passing in the age. So once I have the age, I don't need to take another parameter like year of birth, because if I have the age, I can work it out the year of birth based on their age and the current system time. So in that case, what I will do is self dot year of birth is equal to, I'm not using any math functions, I'm just using the current year here, and 2025 minus age. Here, hello, you are born in, then I will do self dot year of birth. What happens if I do this one? It said you were born in 2024. If I do, let's say 10, then it will be 2015. And if you don't specify anything before this variable, then it is a public variable. If you specify single underscore, then that is a protected variable. If you specify double underscore, then that is a private variable. So the difference between the protected variable and the private variable is protected variable can be accessed by the classes they imported that, whereas private variables are not allowed to access anything outside the current class itself, not even the inheriting members. So I will show you that in action here. Okay, so I've got this class, I've got this protected variable and everything. We have seen this one. Now let's talk about inheritance. When we talk about inheritance, it is easy to understand this protected and private variables here. So the inheritance can be done in Python this way: the class student, and within the brackets the class which you want to inherit this from. So here the person becomes the base class and student becomes the derived class. And similarly, I have an constructor, the first name, last name, and age. And because this guy is in, this student is inherited from person, I want to call the parents the base class constructor with the same parameters I got. That's all I have in this one. I don't have anything else. So now I'm creating the student object here. Student developers heaven, age is 10, and print say hello. Okay, I have not executed this cell. Let me do that and then say hello. You see the year of birth. You were born in year of birth. The student attribute has no object year of birth. So it did not inherit that. If I, oops, this is underscore and here it should be underscore as well. That's the problem. Now if I execute this, okay, I did run this, I did run this, I did run this. Okay, you were born in 2015, which is good. Now if I convert this into a double underscore, which is a private variable. It's not a protected variable anymore. So protected variables have access. I mean, the derived classes can access the protected variables, but not the private variables. Okay, let me just do another function here. Self dot year of birth, and if I do this underscore underscore student year of birth, so year of birth is not there. It is saying that if I do a single underscores here, this will become single underscore. Right, now it worked. So don't get confused with the amount of errors you have seen here. So what happened basically is this year of birth is not there anywhere in this student class. You see, this is actually coming from the parent class itself, the person class. Because I have this single underscore, I am able to access the value in the derived class. But if it is double underscore, I won't be able to access that, because that becomes a private variable. So I will add a comment here. I'm going to check in this code into GitHub for you to reference, but I will just add a comment here, right? No underscore is public, underscore is protected, underscore underscore is private. So now you must have understood if there are any functions or variables which you want to expose it to the derived class, which means the derived classes will benefit from these variables, then use a single underscore. But if you think, no, this is only for this class, any classes that are inheriting this class should not have access to that one, then you will need to do double underscores. I hope you got a good understanding of this classes inheritance and private and protected variables by now. And then the last thing in this topic is the modules. So there are so many modules Python provides. So if you want to inherit modules, you have to do this. So from date time import date I'm doing, then I can print the date here, and from import time, this is how I do that. If I have to import, let's say import SQLite 3, then I can just do this one, and SQLite 3 that I can just use it. That's how we import modules in Python. There are so many modules in Python that you can use and benefit from. That's all I have for now. I think I've covered most of the topics. I mean the most used ones. In my upcoming videos, I'm going to show you how we can actually create web APIs using Fast API, Python, and other stuff as well. So keep watching this plays. I will see you in the next video. Thank you.